So welcome everyone. So we're going to be covering the ability, the value, and the complexities around real-time data integration with legacy applications. So there's an inherent challenge around this in that legacy applications very much like to exist in the batch world, and everyone is used to dealing with that. But the business is asking for a lot more from these processes these days. Getting data at the end of the day is no longer suitable. So just a brief introduction to myself. As Anisha mentioned, my name is Bradley Flemming, Senior Sales Engineer for Fivetran. So she introduced me as coming from HVR, just so that everyone is aware. Late last year, around October, November, Fivetran, which is in itself also an integration company, acquired HVR. So we're now one company. And that brings together a lot of capability. It brings together the capability of HVR that I'll be talking about today, which is this legacy application and real-time enablement, as well as the Fivetran piece, which is very much focused around SaaS API connectivity. So if you've got your applications in Salesforce, you're using Zendesk for support, you're using other Salesforce-based applications, you're using Workday for HR management, we can still integrate and provide real-time changes from those SaaS applications as well. So that's me. And the topic is moving data into the cloud. So why accelerate towards cloud adoption? The cloud, as everyone knows now, it's providing huge benefits, it's providing huge ROI, and it's making the complexity, the risk, it's reducing a lot of risk around managing data. It's moving that complexity from their own teams, from their own IT systems into the provider, whether that's AWS, whether that's Azure, or whether that's Google, or whether it's a private cloud provider that you're using in your territory. You're all gaining those benefits. So security, we just had a great talk around security. Up there on the top of everyone's list is security. And these cloud vendors, the three main cloud vendors, are tier one security providers as well. The ability for them to actually secure their own data, and it's not insignificant data that they are controlling and securing, is second to none. So security is a given with these cloud environments, but also scalability. Hey, we're starting out, we're moving to the cloud. From day one, are we going to move 50 petabytes of data? No, we're not. We're going to do it incrementally. We want to understand how that scales, both technically and commercially. And because you have that, ability to scale up, scale down, that provides a lot of flexibility. Again, technical flexibility. Where do I need to put my data? What should I be adopting? The cloud is a complex environment on its own. We're now seeing cloud data architects, cloud engineers. That complexity is moving from on-premise to the cloud. So we're transferring that cost as well. So we want to understand what the cost is going to be. And why should I go with Azure? Why should I go with AWS? What happens if I go with GCP? Are these in my territories? Do they have local data centers in my territory that I can move data to gain those efficiencies and operational flexibility that I need? And then when we move the data and we start moving and working with that data with our new tools, maybe we're going to discover we can come up with some products, some data products that will enable our partners, suppliers, customers, other parts of the business, to recognize new streams of revenue. We could come across data opportunities that we didn't know we had before because we can really work with it in one place. So there's a lot of challenges around cloud adoption. What do I move first? As I said, I could have 50 petabytes. That could be spread across 20 applications. The business I'm in could have grown by acquisition. If it's a bank, I have acquired other banks, regional banks. I've acquired IT companies and personnel and all sorts of other things to support the operation of that organization. So, this could really determine understanding what you've got within your infrastructure environment and the volumes of data that you've got, how rapidly that changes, can help you understand which cloud environment is right for us. It may not be just a simple geographic decision. It could also be, well, we've got two cloud providers. Maybe I want to understand what both of those have to offer. And in fact, today we're seeing active strategies to not go to a single cloud provider. So we do see businesses now looking to adopt a multi-cloud strategy because they don't want to be locked into a single cloud, because they want large-scale redundancy. These companies, Azure, AWS, they all provide an enormous amount of built-in redundancy, failover support, high availability, just by the nature of their own business. But they also give you, if something critical happens, having a multi-cloud strategy still gives you the platform, the second platform to run your business against. How can our businesses work together? I'm not going through a cloud migration. I'm going to keep some core systems on premise because the risk of actually switching those off is too great. Just for the money it costs us, the investment it costs us to maintain perhaps a relatively large scale SAP deployment is that's enough for us to pay and not have to worry about moving that to the cloud. But a lot of other applications we are going to move. So how can I synchronize data between on-prem and cloud environments? The data movement may not just be one way. It may not just be from on-premise to cloud. There may be additional activities going on where we need to move that data back to on-premise from the cloud. And what training does my team need? Where and how much do I need to invest in making sure that my existing team is going to be just as efficient at working and just as useful for the organization as they are at the moment? I need them to be ready and skilled for the future. And then it's understanding all those complexities and then trying to figure out, how do I budget for this? So we can see there are a lot of challenges around this. People generally see it as a technical challenge. They tend to focus on, how do I move X into the cloud? As you can see, there's a lot of other considerations that come into it. So real-time analytics, which is where HVR and Fivetran come into play, that's really what we're about. It's about making that operational data available in the cloud. So we're seeing things like data warehouse. In the past 5 years, thanks to Snowflake, the data warehouse has had a massive resurgence. The data lake, what we were told was the silver bullet 5 years ago, 6 years ago, in terms of getting all your operational data. It can handle your structured, your semi-structured, your unstructured. The data lake, the world of Hadoop, it's dying. It's now a legacy. But some businesses have made an investment. Some businesses are getting an ROI out of it. Maybe they want to move that to the cloud as well. And the technologies that support data lakes are changing as well. There's now a real hybrid emergence happening between the data warehouse and the traditional data lake. And we're starting to see that being called this thing a lakehouse, which is where Databricks are really trying to make a push in terms of this amalgamation of functionality of traditional data warehouse and the advantages that the data lake gave you, trying to reduce the complexities that traditional Hadoop environment gave you, where you needed very deeply skilled Java engineers to work with that. Now they're looking at leveraging existing SQL skills to be able to work with those platforms. How do I move my terabytes of operational data into these? Another consideration. Is that a single lift and shift? Do I do this iteratively? Do I pick critical tables? Do I pick fast-moving tables? And then once I've moved it, it's instantly redundant. That data has changed. So how do I keep that data up to date without having any negative impact on the source operation? So the reason why batch processing has emerged and is so widely used is because it doesn't interrupt your SAP system, your financial system, your Oracle financial system, your ERP system that's running your logistics, your supply chain information on an iSeries AS400, running it on SQL Server. As soon as traditional batch processors read data, they lock those tables And that means any application running on top of that is going to stop. So the ability to be able to read those changes as they are changing without locking any of those tables and allowing those applications to continue, the users to continue running your business, that's the real challenge. It's incredibly difficult to do, but HVR enables that. And we can keep that data synchronized between on-premise and in the cloud in a near real-time fashion. I won't say real-time. If there are people with banks who represent banks on the line, they'll have a very different definition to real-time. But certainly we're talking within seconds, easily within a minute, to be able to keep the data synchronized. Then how do you know your data is correct? Once we've moved it, how do I validate it? How do I know I've actually moved 50 terabytes of data? How do I know it actually represents the source? How do I know I don't have gaps, missing records, or if I do have the same record, that the state of that record is accurately reflected in that data warehouse environment or data lake environment that I've moved it to? So we overcome those challenges. Do I do this in chunks? Do I do it in phases? Do I do this iteratively, or can I do this all at once? Because it's going to make it easier if I can just do this all at once. They are capabilities and questions that we're able to address. So then the question that a lot of businesses sort of wrestle with even today is, what do I move my data to? There's Snowflake telling me the data warehouse is the place to do it. I've still got data engineers who have a vested interest in maintaining the data lake. I've spent a lot of technology, a lot of money and investment in our data lake. Wouldn't it be simpler and more cost efficient if I replicate that into a cloud environment? But then there's this lakehouse. Databricks is now extolling the virtues of the lakehouse, of being able to have this hybrid approach. Do I need that? Which one do I need? Well, let's give you our bit of advice, our 2 cents on this. The data warehouse is for structured reports. If you're taking columnar data from databases, relational databases, if you're taking reporting information, you're taking spreadsheets, that's heavily structured data. Stick to a data warehouse that is going to suit your needs down to the ground. Even modern data warehouses such as Snowflake, such as Synapse, BigQuery can handle semi-structured data. And by semi-structured, I mean things like JSON definitions, JSON files, XML files can also be queried, managed in these modern data warehouses. The data lakes, well, hey, I've got PDFs of contract negotiations, of invoices, and I've got metadata that relates to these images, to these PDFs, to these things. I've got recordings from call centers, and I've got metadata with those recordings that tell me who the customer was, who the supplier was, who the employee was, how long it went for, some notes that were taken at the time that I want with the actual MP4 recording. So the data lake is the place for that. That's where you can merge your data, much as you already have with an existing data lake, and then do that advanced analytics between your structured, your traditional operational data, and the outside data, the edge case data that enriches that core operational data. And then we've got the latest silver bullet, the data lakehouse. So what this is really bringing together is the data warehouse and the data lake, the ability to really manage, those really unstructured data sets with the semi-structured metadata, with highly structured operational data that's coming from SAP, that's coming from financial systems, logistics systems, ERP systems, banking systems. You can all merge that into one place. And the advantage of the lakehouse, not only is it just a merge of managing structured and unstructured data, but it's also making it a lot easier to analyze that data. You can use standard SQL code. SQL is really emerging as the most efficient analytical tooling that people can work with. If you want a skill set for the future for dealing with analytics, SQL, understanding SQL code and being able to write reports in SQL means that you can work across all of these platforms. So the skill set that your staff that need to work with that data really needs to be focused around SQL, because all of these are really strongly supporting the ability to run standard SQL queries. So which should you choose? Okay, you've made the decision to go with this new data warehouse. It's not the Teradata that we had on-prem. It's not going to be the Oracle Exadata or a massive collection of databases that we've got on-prem that are enormously expensive to put more data into, to add additional disk into, to maintain. No, we're going to go with a cloud data warehouse that can be Google BigQuery or Redshift or Snowflake or Azure Synapse. Every vendor is offering their flavor of this modern data warehouse. With the data lake, we are looking at AWS S3. This is raw file storage with separated compute. So that is the, if you like, that definition of the data lake. It's very highly separated compute and storage. AWS S3, using the AWS Hadoop clusters that they provide. Azure ADLS Gen 2 with HD Insight. Google Cloud Storage with their own services for Hadoop. And then you've got standard HDFS as well. That's all on-prem, that can now move to the cloud. All of those offerings offer HDFS support. And then we've got the Lakehouse offered by Databricks. And Databricks is running on all three platforms, much like Snowflake. You know, it's the product that sits on top of the infrastructure that they provide. So, you know, we see Azure Databricks, we see AWS Databricks, and we'll see Google Databricks. And that means you can run much like Snowflake. You don't have to think about, oh, do I want this running on GCP? What am I going to get that's different? No, you get the same functionality, you get the same Snowflake Databricks experience across all of those platforms. So again, that can make the decision a lot easier for some organizations. You know, if I'm going to go to Snowflake, I don't really have to think too much about whether it's Azure or AWS or Google. Same with Databricks. You know, the underlying platform, kind of irrelevant unless you're also doing other things as well. You may be using ADF in Azure. You may be using Glue in the AWS environment. So it's offering a lot of capabilities about where you can work with that data, where you've made existing investments with your skills. So why do people do this? Why do people look to do this? We've had several customers come to us and ask for help with this. The reason is complexity. This is a real life example of a company. They don't allow us to share their name, so we're calling them Company X. But this is what they had. So they had SAP ECC. They also had Sybase. And you can see they were using a multitude of tools. They were using every angle by magnitude. They're using SAP tools to deal with SAP. They're using DB Moto to deal with the Sybase technology. They're using Informatica to deal with Microsoft and Oracle database technologies. And then they were moving data directly into reporting capabilities. They were moving it into Redshift. They were using S3, swapping data from S3 into Redshift, vice versa. They were also using SAP HANA, and each of these had their own reporting capabilities coming out the back of that. So you can see the complexity. You can see the scale of vendor management that had to take place. You know, it was multiple contracts being looked at, making sure that we had people skilled to use each of these platforms, each of these technology sets. And then there was the complexity of security. You know, there isn't a single line through that firewall. We see 6 or 7 different lines that have to go through the firewall. So there's multiple risk points being introduced there. And then the supply chain reporting is actually, you know, it's down to a single feed. Finance reporting is the result of a single feed. So it was very linear, very rigid, not very flexible, and probably not a very good ROI with that architecture. We came along, they had discussions with us. They wanted to understand what HVR could do in terms of addressing the data in these environments. And we really simplified their landscape. They persisted with every angle by magnitude for Sybase. They also used us for everything else. So SAP real-time replication, Oracle real-time replication, Sybase real-time replication, Microsoft SQL Server real-time replication. So those 6 or 7 holes through the firewall reduced to 2. We're able to take all those data feeds using a single tool, not multiple tools, not 6 or 7 that you saw before, feed that data into Amazon Redshift, into S3, into SAP HANA. We could direct all of the data into each of those 3, or they could discretely manage those different feeds into each of those technologies. And then the integrated business intelligence had access to all the data. It wasn't a fixed single feed that they were getting the reporting from. It covered all of their data. The data science department could work with all of their data in that raw environment that Amazon S3 provided them. Data scientists love using raw data.
Bradley, I'm so sorry to interrupt you. I request you to please wrap up your presentation. We're over on time.
Okay, so the simplification is really the advantage. We offer a lot of capability around copying, continuously streaming the data, being able to validate that data, streamline that. That gives you just a simple tool to move all of that data, no complexity, 0 code. You know, we're not asking you to do the data type mapping. We're not asking you to create the tables, and we can verify that data by using a compare functionality. And with that compare, we can also repair. So if we do identify holes in the data, we can also repair that data as well. So that doesn't mean you have to go and look for these holes and figure out how do we align this data. We can align that data for you. And again, we see an emergence of moving data backwards and forwards between source and target. So this is really a phrase that is emerging is reverse ETL, but really we can support data movement in multiple ways around. The key way we do this is log-based CDC. Have I got 1 more minute, Anisha? I'm going to keep talking then. So
I request you to wrap it up, Bradley.
Okay, so last slide that I'll talk about, it's non-intrusive, it's very low impact. We just read the changes from the logs on the database. It's highly secure. We encrypt the data. We can make that data move in real time. And the coverage that we have is really covered in this slide here. So this is why large, complex organizations like us, we can get our arms around, we can help them manage a lot of different data sources and help them move it not only to the cloud, not only to data warehouses, but to other data repositories as well. And I'm going to leave it there, Anisha. So if anyone has any questions, they can ask that now.